Good morning to all the professors, assistant professor and assistant professors present over here. A gracious welcome to all for the one-week faculty development program sponsored by AICTE, Training and Learning, ATAL Academy, Future Trends in Energy Management for Smart Cities, organized by Department of Electrical and Electronics Engineering from LENDI Institute of Engineering and Technology. It gives me a great pleasure to present the resource person for today's morning session, Dr. L. He is the founder and director of Radhan Technologies Private Limited. Coming to his academic profile, he has completed his B.Tech in Electrical and Electronics Engineering from Sasi Institute of Technology and Engineering, Adepalligudam in 2008. He has completed M.Tech Instrumentation Control System in University College of Engineering, JNTU, Kakinada in 2010. He has completed his PhD in NIT Andhra Pradesh, Adepalligudam. He served as an associate professor in Department of EEE at Sasi Institute of Technology and Engineering, Adepalligudam from 2010 to 2020. Coming to his research profile, he has published great research papers in reputed journals like IEEE, elsewhere, etc. He also has presented papers in various international conferences. In addition to this, he has published 4 Indian patents. Thank you for this opportunity. Now I request.
It's my immense pleasure to invite our resource person today. So I request Dr. L.N. Sastry garu to please carry with his session.
Good morning, one and all. All the faculties from various colleges in and around Lendi Institute of Technology and Engineering. Today, I would like to briefly explain about what is a smart city and where smart cities, how the integration of renewable energy will be available in smart cities, and what are the various energy management techniques used in smart city case, and various tools available for managing energy managing or energy monitoring of various smart homes or smart buildings. There are various tools available. If time permits, maybe half an hour or 1 hour session, I will take a hands-on session on Python coding using energy management techniques. Most of the cases, present day, papers or any research will be without Python or without machine learning and deep learning. Okay, research which is conventional research was not be published present day scenario. So that I just implement some of the algorithms in machine learning and deep learning using Python. Either maybe a Keras, TensorFlow, or a PyTorch environment. Do you know Python? Anyone? Python known to you? Someone. Okay, fine.
Small request. If you were on the dais, we could have the live video.
Okay, fine. PPT check. Okay. First, I would like to define a smart city first. Anyone here present over here have an idea about energy management research? Have you done any research or any papers on energy management or any core areas only? Energy management, no idea. Okay. managing the energy is the key role of an electrical engineer. Not only manage, we need to audit the energy first for managing the energy. There are so many cases that is auditing of energy. Auditing in the sense we always have an audit of files or inventory audit or stock audit will be available in our regular day-to-day academic activities. But energy audit is not done in most of the institutes and most of the companies. Okay, energy audit. What is energy audit first? What is energy audit? To know where the energy is lost or energy is wasted as a loss. There are so many losses available. In India itself, there are 15 to 20% of losses will be available overall the transmission and distribution cases. Clear? So that if we identify the losses by using an auditing process, there are so many auditing processes are available, which are preliminary audit and a detailed audit will be available for an energy audit case. In those cases, we identify where the energy is lost as a AT and C losses, and that losses will be minimized in the subsequent steps by management and control of that particular loads individually. Clear? In the smart city case, today my talk is on energy management for smart cities. Smarter enough is nothing but presently we are in an era of Industry 4.0. Do you know Industry 4.0? What is Industry 4.0? We are in the era of Industry 4.0. Industry 1.0 is completely on steam engine and steam engine, and 2.0 is don't know what is Industry 2.0, 3.0, 4.0. Now we are in 4.0. What is Industry 4.0? It is nothing but a cyber physical system. Any physical component or any physical load, whatever may be the case it is, whether it is a mechanical, whether it may be electrical, whether it may be any component which is connected to internet through an IoT, and it can be monitored each and every second lively by using a cyber physical systems. We are connecting each and everything into a internet, and due to the connection of all the equipment to the internet, and we are lively monitoring and collecting the data minute by minute or based on the frequency of sampling. We have a sampling period of 1 second or 2 seconds. Based on the availability, we modify the sampling period so that the data will be more and more data. If I put a sensors on each and every fan of this particular room, for a 24 hours a day, I collected the current voltage and power drawn by that particular fan and abnormalities when the fan will be taking high current or low voltage, which are the abnormalities of the load. Those abnormalities are captured by using a sensor for each and every load which is connected to internet, so that the data is populated to a huge range. For that particular data, to process that particular data, the basic algorithms which we have, signal processing is there, we have Fourier transforms available, we have various conventional optimization techniques and meta-heuristic algorithms are also available. In the previous case, because of the data population and the increase of data, due to the cyber physical systems, these larger data cannot be handled by the basic optimization techniques, and we are moving into the energy management of this particular complete data through a machine learning or deep learning case. Their artificial intelligence, which is a smartness or intelligence, look into the picture. Okay, intelligence is added to that particular data so that we can able to control the data, or we can able to access the data very use data. Okay, it may be of GB of data, it may be of KB of data. KB is very less. In the previous days, we process that KBs of data by using a meta-heuristic and optimization algorithms like genetic algorithm, particle swarm optimization, ant colony optimization, like bacteria foraging, and multiple algorithms by combining two or more algorithms. Hybrid algorithms also available in the previous days, and signal processing also available in the previous days. But those algorithms are not suited for the large data, and the complexity of data is increasing, and the complexity of algorithm is also increasing to handle that much of data. So that we are moving into a smarter way, that is an intelligent way, where we are using artificial intelligence and machine learning techniques into our energy management, that is your smart city. Where in a home we have only the load data, and we have only the electrical loads which are connected to the sensors and collecting the data from the electrical loads. In a smart building, that is called a smart building, energy management in smart building. Whereas coming to a smart city, we have everything smart. What is everything? Everything comes under, we have a waste management, we have a transport, we have a water supply, we have a gas supply, we have energy supply. Whatever may be the case it is, the each and every parameter of a city and an urban village or a city will be smarter enough. We are connecting all the things into an internet by using an IoT and cyber physical systems, and collecting the data, process that data, and control that particular data through an algorithm. Nothing but a smarter way of controlling and monitoring of that particular parameter, whatever may be the parameter it is. Moving to this, I just brief about those. I would like to discuss these things: smart city and energy management introduction, energy infrastructure and technologies, advanced techniques like AMIs. We are popularizing AMIs. Previous days we have all the equipment which are analog based. After that, analog based energy meters will be transformed and rolled out and converted into a digital meters. Even then, there are so many losses available corresponding to that data reading and billing information. For that, some prepaid meters will be introduced in some countries like Tier 1, Tier 2 cities. After that prepaid meters, there are advanced metering infrastructure is also available, and smart meters are also introduced in some countries like Haryana, Delhi. In those cities, smart meters are also connected not only for energy, those can be connected to water, gas, and energy. For both three cases, they introduced smart energy meters. What is the water supply? How much gallons of water is consumed by a particular user or a particular customer for a particular month? That can be calculated by using a meter. That is a smart meter also. That is smart meter. Again, what is the gas supply? Gas supply, how many kgs of gas will be consumed for a particular 1 month period, and energy also. Even then, we are introducing a smart energy meter into a energy scenario. We don't have customized smart energy meters in the market. Customized in the sense, if I go a shop or a grocery shop, I purchased some of the items which are needed for my household purpose, and I have a bill at the last, which costing around 2 to 5,000. Let it may be. Without any itemized billing, will you accept that bill? Without itemized bill, will you accept that bill? Item 1, this much amount. Item 2, this much amount. We cannot accept in a grocery shop, but we are accepting in an energy case. In an energy consumption case, we are accepting the bill. This many units are consumed by you with this particular month of June, and the bill corresponding to your energy is 1,500. But we are accepting. Clear? Even in smart energy meters also, we have no facility such that your fan load is consuming this much load, this much energy, this much kilowatts, and corresponding this kilowatts are this many units. What is the price corresponding to your fan load? Corresponding to your AC load, what is the bill? What is the light load bill? Based on the category of your load, the bill won't be available even though the smart meters are introduced. If I want the categorical bill, that is itemized bill in an energy case, I need to install a sensor for each and every load overall India. Is it possible? I want to collect the information of energy consumed by a particular load, and then only we have an itemized bill. Is it possible to connect a sensor for each and every load overall India? For a particular home itself, I have 100 loads. For 100 loads, I need 100 sensors. For each and every sensor, I need a 5 volt supply again. It is very impossible, and it increases the cost. That's why there are techniques called intrusive load monitoring and non-intrusive load monitoring. All are available in the slides, but I completely done my PhD in that particular area so that I clearly explain. Okay, all are available in the slides. I will move forward later on. There are two techniques called intrusive load monitoring and a non-intrusive load monitoring. Intrusion in the sense. What is intrusion? Intrusion in the sense, I want to intrude particular load and connect a sensor to a particular load and collect the data, collect the energy information corresponding to that particular load. That is intrusion load monitoring, but it is a cost-effective solution, not a cost-effective solution, so that we don't go for an intrusive load monitoring, such that we don't want to introduce sensor for each and every load. And another way, it is a non-intrusive load monitoring. Already all the loads are connected for a particular home. All the loads are connected to a smart energy meter, and the aggregated value of all the loads, that is load profile corresponding to each and every load, is aggregated and collected at the energy meter. Okay. Now, based on the aggregated energy data or the load profile, I would like to disaggregate, or I would like to sense the customized load profile by using any algorithm. Present day, we are mostly using machine learning and deep learning. So that machine learning, deep learning, by using machine learning and deep learning algorithms, I would like to customize or segregate. I have a n number of loads which are connected to an energy meter. At any point of time, I would like to know what is the fan load. Today, what is the fan load corresponding to my home, and what is the bill corresponding to that particular fan load. and what is the AC load. Based on that, we can able to manage the energy within the period of that particular month. Now, present day scenario, we have a bill at the end of the month, so that after end of the month, there is a tariff also available. Up to 100 units, one tariff will be available. 101 units, complete tariff rate or slab will be increased for your energy bill. If that 1 unit is conserved beforehand, if you know the consumption before the hand, that 1 unit slab can be nullified, so that you can able to get into a slab of basic rate. Up to 100 units, let us suppose 3.69 per unit, and 101 unit, your slab will be 6.9 rupees per unit. Then, due to 1 unit consumption in a 1 month of time, one increased unit, you need to pay additional 3 rupees per each and every unit. Clear? So that this is the need of customized energy transactions of each and every load to know the customized energy. If I know, I can able to conserve. Today, I want to know what is the AC load consumed and what is the bill. This many units are consumed by AC, so that I can able to reduce that particular consumption in coming days beforehand, before the bill is generated at the end of the month. I can able to conserve. Then the waste of energy also reduced. And if I have a prosumer, what is prosumer? If I have a prosumer, I am not a consumer, and I am a prosumer. What is a prosumer? Producer, consumer, combinedly known as prosumer. Prosumer in the sense which will generate energy. The consumer, which will generate energy and consume energy also. It means I have a solar panel at my rooftop. I can able to generate energy. I can able to consume energy from the grid also. Whenever the solar is not available to me, the energy which is coming from the grid can be utilized for my daily needs. If the solar is available, that will be utilized rather than a grid, and excess power is again pumped to the grid. That is prosumer. This prosumer, if it is a prosumer, now I am adding a renewable energy source into my local grid. This is nothing but a microgrid rather than a complete grid. I have a microgrid at my home itself. Due to that microgrid or a renewable energy integration, I can able to generate energy, and I can able to earn money also in return. When it is possible, I have a customized bill only. Due to that can be done by using a non-intrusive load monitoring. I will show you. That is for this one. Previous slide. Here I discuss all those techniques. Advanced technologies in energy management. There I discuss all the techniques. These are all basic smart city and energy management in smart city, energy infrastructure and basic technologies. And there are various tools and softwares also available for energy management itself. There are different tools available, and the tools are already developed as a GUI based, as like your app based tools available. Your mobile app is there. Directly your mobile app, you can able to add a load and control that particular load. Likewise, GUI based, web based apps also available, and also mobile based apps also available. Okay, the tools I will discuss. So many are available, and some research opportunities in this energy management. Next, this is the smart city. All will be smarter enough. Where I mostly concentrated on energy only in this case, in the previous discussion, that is smart building. Building is smarter, your governance is smarter, education is smarter. How education is smarter? Due to ICT tools. By the introduction of ICT tools, in the previous days, only the blackboard teaching is available. Only the teacher-student teaching is available. Now, self-learning is available, MOOCs available, ICT tools available, various teaching methodologies will be introduced. The same concept can be learned in number of ways. Whatever way you want, you can learn. That is the student choice. Clear? That is smarter education, and then infrastructure is also smarter by connecting all the components into a IoT. We are introducing an IoT technique, Internet of Things. The thing is your physical device. Each and every physical device is connected to the internet nowadays. That is smart infrastructure. And transportation is smarter. We can able to track the location of each and every transport vehicle. I can able to track my vehicle by using a GPS. That is also a sensor. Clear? How much distance it is traveled. That is also I can able to track by sitting in home and access to the internet. We can able to do anything. Clear? That is our smarter transport and smarter mobility. And then water and sanitation is also smarter way. In the smarter way, we connect all the water and sanitation purposes also in smart case. And then planning, town planning is also smarter. Smart energy, all the energy equipment is connected to intelligent sensors. Healthcare is smarter, security is smarter, complete building is smarter. Likewise, by connecting all into an intelligent system, my smart city can be defined like this. The urban area which integrates digital technologies into its infrastructure services is called a smart city. That is the definition of a smart city. A normal village which is converted into a smart village by introducing a various digital technologies and connected to internet. Okay, this is one of the motto of Modi. Some of the cities should be by 2030, 1,000 cities in the India should be smart enough. That is the motto of Modi. Next, and these are the key components of smart city. We have ICT tools for connecting everything or anything to internet. That internet can have access to each and every component of your city. Whatever may be the component it is, whether it is a medical, whether it may be of water, sanity, or it may be an infrastructure, it may be a mobility, it may be of human can also be connected to internet. How? Using a smart device. Your daily activity is also recorded. By wearing a single smartwatch, how many steps you are moving in a day, what is the heart rate each and every minute, and those are by creating a simple Microsoft account or a Google account, the complete data of a person is also recorded. By using your mobile phone itself, your mobile phone data is also recorded. How many calls you are attending, how much time you are spending in YouTube, how much time you are spending in web search. Likewise, the complete personal data is also available. That means a human is also connected to a city. That is smarter way. That is Internet of Things. That thing is also a human. Okay. And based on this collection of data by using ICT tools, we need to take the decisions. For what purpose we are collecting the data? We are collecting the data by using different sensors and IoT techniques and store the data in a platform that is a cloud-based storage that can be accessed revert back, and based on that particular data we need to take the decisions. that decisions can be taken by using data-driven decision making. Data-driven decision making is based on the previous data which is available in our database. This is the trend which is followed. Some of the data will be trend following data, and some of the data is some abnormalities. When abnormalities happen, what is the decision that can be done? And that decision making is also by using the internet. That decision making is also an automatic decision making. In previous days, that will be a man-made decisions, and the man-made decisions can be delayed. Let us suppose for an manufacturing industry, because all are electrical, I go into electrical point of view. There are valves which are controlling various flows in a particular manufacturing industry. That valve control is controlled by a PI controller. In a previous days, the PI controller tuning can be done, and based on the tuning of PI controller, the valve position will be decided, and the position will be given to a particular person which is looking after that particular supervisor after that particular valves. Some sections will be allotted to a particular supervisor, and that supervisor will go around to that particular valves and modify the positions like 30 degrees angle, 40 degrees angle in the previous days. Now by using a SCADA system, all the position control systems, all the valves which are available in a manufacturing industry, whether any manufacturing industry, that can be connected to a SCADA system, and only one person is controlling through a SCADA, because it is digitalized, and by using a SCADA control system in a control room itself, he has taken decisions, and the decisions will be implemented in the software, and the same software decisions will be again implemented in a hardware point of view. Now the total manpower is reduced to a single person and a single computer. That is the digitization and automation happen in an automation industry. Clear? Each and everything is automated now. If it is automated, there are lot many data will be available. For each and every valve I have a data. That data based on the previous data, at which position the valve will have a highest flow, at which position the valve will have a highest pressure. That is the previous data which is available. The history of data, that based on that history of data, we will take decisions in the future trends. That is called data-based, data-driven decisions that can be implemented in the smart city. And then sustainable infrastructure. We would like to prioritize the things which there are so many actions or so many inputs are available to a particular algorithm. We need to prioritize the things. At which case or at which situation which is to be prioritized. Okay, which is to be prioritized. For a, let us suppose for a traffic control system, I modernize this traffic control systems rather than a simple traffic inspector which is available at a 4-road junction. I modernize the traffic control system by using a microcontroller and IoT. Clear? All the roads are controlled by using a automated traffic control. An abnormality like a ambulance will come at a particular road, then it will take a decision at that particular point of time by sensing the ambulance, either by using a sound or either by taking a picture like that. It will sense the ambulance and it has to clear the road in that particular path, and it will take the decisions. Now the priority is for ambulance rather than all the other vehicles. My priority is ambulance. There, my microcontroller program has to be prioritized by using a priority inspector that is available in the microcontroller program. Whatever may be the program it is. Not only microcontroller, maybe some other controller using intelligent decisions. Clear? That has to be prioritized in energy case also. And then citizen engagement. These are the various components of smart cities. Next. Next slide. Now, we are managing the energy in a smart city by connecting all the loads or all the energy driven or energy based loads to a IoT. For what purpose? What is the importance? What is the importance of energy management in smart city? These are the basic things. We need to monitor the system minute to minute. We can able to monitor the system if those are connected to internet, and a single person can monitor each and every device rather than inspecting. In previous olden days, in an electrical distribution case, there is a line inspector is available and a lineman is available. Do you know the roles of line inspector and lineman in a transco? Line inspector and lineman. The line inspector duty is for every day morning at 9 a.m. he has to sign in the register and he has to assign a fader. A fader in the sense, a fader which is traveling for a particular distance, and the tappings of the fader can be connected to different transformers, and the transformer is feeding all the homes which are available in that particular street. Okay, for every fader, the line inspector has to assign duties for a particular fader, and he has to travel along the fader and inspect whether any breakdowns happens. What are the breakdowns happens in a fader? I have an insulator breakdown happen. I have a corona effect, Ferranti effect, corona effects will be happening at that particular fader, or any short circuit will be happen, maybe of LG fault, triple L fault, due to the fall of any tree or fall of any bird onto the particular line. This can be inspected by a person, and again a lineman will rectify that particular fault in that particular subsection. Then only the power outage will be rectified in the previous olden days. Now all are connected to a simple technology like, what is the technology now? How that can be intimated to a substation? What is the technology? From substation to substation, and in a substation from fader to fader. The technology is power line based communication. I have a substation at one particular place and I have a substation at another particular place. The communication between these two substations will be done by using power line communication. The power line which is traveling throughout the particular substation is acting as a data or acting as a communication channel, and they send the information by using power line communication by the technique called OFDM, orthogonal frequency demodulation, OFDM, or frequency shift keying, FSK, and QPSK, query phase shift keying. Like that, there are different quasi phase shift keying. Like that, there are different techniques in that particular signal processing. By using those techniques and some protocols, there are different protocols available. For internet, there are some protocols, and for LAN, there are some protocols. For Wi-Fi, 802.11 is a protocol like that. Like power line communication, we are using CAN-bus protocol. By using a CAN-bus protocol, we send the information of a message by using a modulator and demodulator case. in ECE based students, it will be very much familiar topics. And but for electrical, these are new topics, but we need to connect those things. We are using those things nowadays. Okay. That monitoring can be done if the energy management is smarter. Okay, rather than a human inspecting each and every fader, and the outage has to be reduced by a human. It takes a day, or in some days it is a week, it is a month also, if it is a heavy fault. Okay, so that the damage is high. If a particular fader, an industry is available, up to 1 week, the industry is shut down. What happens? The complete employees will be losing, and the manufacturing is lost by that particular industry. So many loss will be available for that particular case. That monitoring is available. We can able to collect the data and verify the data, and we can able to calculate energy usage each and every point of time. And we can able to plan the available energy. Plan in the sense in the future case. I have connected a maximum load of 1 kW and I applied for a 1 kW meter at the initial stage of my house newly constructed. Now I would like to plan to add new loads. New washing machine is bought and new fridge will be bought, and like that we are adding day by day. We are adding loads to that particular home, but the connected load is 1 kilowatt only. What happens if it is connected load is 1 kilowatt? We are using more than 1 kilowatt. What happens? The bill will be high, and we need to upgrade that particular meter to a 3 kilowatt or a 5 kilowatt if we install any another load. For that future planning, we need to assess the energy usage of a inside home or existing infrastructure, and if that particular energy usage, for every day we need to calculate each and every fan, 80 watt, 80 watt, 15 watt, 16 watt. We cannot able to calculate for every day or every minute. That can be given by using an energy meter directly by categorical analysis of data, categorical billing, fan load. The complete fan load will be utilizing this many watts. Likewise, if I sum up all those things, my total load will be, the consumed load will be available. Maybe 5% or 10%, it may be varied. Okay, based on that, we can able to plan in the future how much load I can able to add into a particular home, but not only in a home, in a bigger scenario also. Clear? That can be done. We can able to plan energy, and then we can able to organize and implement. These are all I just given as a point by point. Next slide. Same system. Next. These are the various components in a smart city. Buildings are smarter. How the buildings are smarter? Which are connected to a smart grid. Each and every building is connected to smart grid, and we can able to improve the conditioning system, and we can able to improve lighting and control, heat recovery and storage, hybrid ventilation system, HVAC systems. We call it as HVAC. What is HVAC? Heat ventilator air conditioning. Okay, that all will be connected to a smart grid, and we need to control, monitor and control. That will be available, and we can able to high efficiency generators we will be using, and some solar rooftops also planned for a building scenario, and water management. These are the aspects of a water management. And for a transport and for a waste management also we can able to get. From waste also we are generating energy nowadays. Even for a human waste we are utilizing it as a energy. And a waste from plants, waste from vegetables, all the vegetable waste can be fragmented and that particular waste, based on that particular waste, we can able to generate some gas, and that gas converted into a fuel cell, and then fuel cell can generate energy. All will be done. Like cow dung, but from the cow dung itself, we are generating methane gas. Methane gas based gas, we can utilize gas as a methane gas. We can utilize that methane gas as a substitute of hydrogen gas in a fuel cell, and we can able to generate energy also. Methane gas based fuel cells also available nowadays. Likewise, for each and everything in a smart city, we have where not only energy is matter, not only building is matter, everything has to be connected in a smarter way, or everything is optimized, or everything should be managed in a smarter way. Clear? Waste management is also a smarter way, and then public services also in smart way. Smart street lights, smart road walks, like that. Everything will be connected to smart. Thank you. And this is the global scenario. I add this slide due to the last point at a globe. Smart cities, energy management at a globe, that is the topic. This is the complete global scenario, and I plotted, this is taken from a world data where our India is. This here the India is available. Plotted the CO2 emission versus cost GDP per capita. If I decrease the CO2 emission, and I can able to increase my GDP also. Clear? This is the per capita consumption in tons. 0 ton, 2.5 ton, 5 ton, 10 ton, 15 ton. This is the CO2 emission per capita, and this is the complete GDP in dollars. We have midway between the maximum limit and the minimum limit. This is where we stand. And beyond that, the lower countries like Ethiopia, Tanzania, these are at a lower place, and some other countries like United States, Canada, Singapore, these are available. Those having CO2 emission is high, and also per capita emission, per capita energy access is also high for them. Okay. Now I would like to integrate renewable energy case. I have different senses like generation, distribution, transmission, like that. Now I would like to integrate renewable energy generation and integration into the grid. That renewable energy can be done in different cases. First case is a rooftop solar, that is a residential purposes. In the residential way, like a micro grid, we can able to generate renewable energy and connect it to a grid. Okay, that is up to how many watts? It is up to 500 kilowatts only. It can be possible from 5 to 500 kilowatts only possible, and generated behind the meter. We cannot able to generate beyond this meter. We are generating inside this meter, and due to the net metering facility, we are connecting this generation and consumption by using a net metering to the grid. Clear? And for a community purpose, in a community, we can able to generate up to 5 megawatt. Up to 5 megawatt, we can able to generate in a community wise, and this community is feeding. This is beyond the meter. Now I am generating at a simple location as a public location. That generator location is beyond the community houses. Different houses I would like to transfer this energy to different houses which is outside the meter. This meter will capture the generation and consumption at this particular stage. This is up to 5 megawatt. Beyond that, it can be industry up to from 20 megawatt centralized utility scale generation. We can have a complete solar arrays or a solar power plant or a wind power plant directly available at a particular space which is at a generation stage, and that can be connected to a grid, and it can be transmitted over a transmission distribution network through our household processes. Clear? This is up to beyond 20 megawatt. For a household, it is up to 500 kilowatt, and beyond that, it is a community and then centralized. Next. Next, coming to advanced metering technologies and energy management in advanced scale. In previous cases, we just connected to a smarter way. Now, all are connected here. Now, I have a conventional power plant, and I have a renewable energy source, and I have a utility which is utilizing, like consumer is available, prosumer is available. Prosumer in the sense it has generation and consumption also. Consumer is only the consumption is available. There is no generation, and all the data-based decisions will be done by using a cloud service. This is the central system where all will be connected together by using a simple ICT and Internet of Things tools, and the decisions will be taken by using a previous data, by using a simple algorithms, whether it may be a normal decision making algorithms or a machine learning algorithm or a deep learning algorithm based on our data which is available at that particular cloud storage. If the data is larger enough and I would like to take the decisions from a larger data, I need to move on to a more prominent way of machine learning or deep learning algorithms to take decisions in a smarter way. If the data is low, then basic optimization algorithms can be useful. Clear? And those are connected each other. Always the renewable energy will give the energy rather than consume the energy, so that all the arrows will be in this case. But I have what is the data available here? The forecast of energy or forecast of data which is available. Forecast of energy generation based on the previous availability for a particular location. Let us suppose for a Vijayawada scenario or Vizag scenario, there are some solar irradiations available, and based on the solar irradiations, how much energy is generated for a previous year. Now, at a spring season, what is the energy generation? What is the energy generation at a summer season? What is the energy generation at a autumn season? Like that, based on season, the illumination will change. Based on that illumination capacity, the solar will generate. We need to forecast the energy. That forecasting can be done by using a renewable energy source. Renewable energy source. That there we can use machine learning algorithm for forecasting. Clear? That is for renewable energy. For a conventional power plant, these are normal hydro power plants, thermal power plants, nuclear power plants. Here also we need to forecast the energy generation by using a machine learning algorithm. These two are the sources of energy which can give energy to a system, where we can use that energy and also give energy by the consumer. That is a microgrid which is available at a micro level, at a home level. We have a microgrid. Clear? We can be able to give the excess of energy to the system, to the power system. Here the system is power system. The complete grid is nothing but a system. Now, the excess of energy which is already utilized, after utilization of my needs, the excess energy can be pumped to the grid here from the consumer. Where the consumer, where there is no consumer here, only the consumption is available. there is no production, so that it is always consuming the energy. Here we forecast the energy generation by using a machine learning algorithm, and here we are calculating the demand. What is the demand available at this particular stage? For which demand, how this forecasted energy from which source I need to route to this particular demand. If I have a 1 kilowatt demand here, my 1 kilowatt demand is met by this prosumer, which is an excess energy by the prosumer. I can able to transmit this particular energy in locally rather than traveling the energy generation from generation to the distribution. There is a much loss available. Present day, in the previous days, that is only the way. The generation is available at a far distance. From the generation, it has to be upscale, downscale from 132 kV to 440 kV, 11 kV, and then 230 volts. In that particular conversions itself, there are so many losses available. Clear? So that we need to optimize the decisions by using any machine learning algorithms or tools which are available with us. Clear? If this is more than 1 kilowatt which is produced by the prosumer, then the shortest path where the generation is available to meet this demand, we assess the demand in these two cases and we assess the energy forecast from these two cases. And the cloud-based service will have a data, complete data of forecasting and demand data. Based on this data, we will take a optimized decisions such that losses will be minimized. Clear? Advanced metric. Okay, fine. Next. This is the complete power system where I just introduced the EV. EV is also a simple load. Now we are introducing the EV vehicles into a power system. Then what is the effect of power system by introducing an EV? Rather than introducing a renewable energy into the power system grid, load is also the effect. There is an effect from the load also. Because I have a connected load of 1 kilowatt, my complete home load will be below 1 kilowatt only. If I add a EV to that particular case, my EV itself has 3 kilowatt or 300 watt based on the capacity of your vehicle. Then it has a much impact on the grid, whether it may be a generation case, whether it may be a transmission case, whatever may be the case it is. Even there is a microgrid available. I have a microgrid available here, that is a rooftop solar is available here, and a EV also available. Renewable energy, and I have a renewable energy source also available here, solar, at the generation stage. This is my conventional generation, and solar is available, hydro is available, and all windmills also available. All the renewable energy case is available at a generation stage and a home level. Rooftop solar is also available, and I would like to add a EV. How it will be impact to a power system? I just given each and every component, and all are connected to a central server. This is my central hub, which will control the actions where it has to be meet the demand without any loss. Clear? Now next. Previous. These are the various impacts by introducing an EV. What is the impact of this EV which is introduced at the utility level to a generation? What is the generation impact? It will increase the use of peaking plants, higher prices at peak. Because if I am using a EV, charge an EV at a peak load condition, let us suppose from evening 6 to 9, that is the peak load condition. If I use EV at that case or charge the EV at that particular period, then what happens? It demands much more energy from the supply, that is from generation, which will increase the cost of that particular consumer. Clear? Likewise for every case. What is the effect on transmission? Transmission, it will increase the transmission network congestion. What is congestion? Congestion is overloading. Additional burden is on the transmission. Because of the peaking condition, at that particular peak, if I use an additional load at the utility case, it has to transmit. My overhead transmission line is particularly designed for a particular voltage. Now, I would like to draw. I am using only one EV at that case, but there are so many EVs. Assume so many EVs which are available at the utility case. If those EVs are connected at a peak hour, what happens? The burden on that particular transmission line will be increased. That is nothing but congestion. And then risk. High risk in the distribution network also, there will be a high risk of local constraints, need for operating networks closer to their limits. The transformer which is connected at that particular substation is also overloaded at that case. That is the high risk of a distribution network. This is for transmission, generation, distribution, and also a utility case. What is the effect on utility? I have a EV at this particular home, and there is no EV at this particular home. Okay, and there is no rooftop at this particular home. A neighborhood home will have a high electricity price at that case. Presently, we are facing that issues. Previous bills will be added now from 2014 to 2019. The energy crisis will be available, and at that case, to meet the demand, governments are purchasing energy from different countries, different cities, or different states. To meet that loss, they are collecting now as a FRCP charges something. There is a effect on neighborhood also in a utility case. Clear? Next. There is also said. Next. Already given this scenario. Next technique is to meet the energy management. We are using non-intrusive load monitoring. This is the case of intrusive load monitoring. I have a room 1, room 2, and there is a loads available in each and every room, and they are connected with each and every sensor. These red colors are sensors. For each and every load, I have connected a sensor and monitored through a sensor. This is a intrusive load monitoring. I just intrude to a particular load and monitoring each and every sensor. Rather than connecting each sensor to a particular load, I would like to monitor this particular scenario by collecting an intelligent sensor at a meter itself. Because the aggregated profile, by combining all the load profiles, will be available at a meter, and I would like to collect the aggregated profile without touching each and every load, so that the cost is minimized to have a number of sensors. I have reduced it to one single sensor. This is nothing but a simple algorithm, intelligent algorithm, where I can able to separate each and every load profile from an aggregated load profile. That is non-intrusive load monitoring. For this, next, what is the case? This is the complete scenario of NIL, non-intrusive load monitoring. In the previous case, we have a meter available from a transformer. I have a meter. From meter itself, the complete home will be supplied power. Each and every load will be supplied power through a meter. Now, this is a complete NIL engine where I collect the data from the meter itself, where the meter has the complete data, where voltage is available, current is available. By using a signal processing technique, I would like to collect the signatures of each and every aggregated load data, and I would like to collect the signatures, features and signatures from the signal processing perspective, and then based on the features, I would like to get the event detections. Event in the sense, my load is on, that is one event. My load is off, that is another event. At which case my load is on, at which case the load is off. That can be disaggregated by using a classification model. That is a machine learning model, whether it may be a classification model or a regression model. Okay? By using a machine learning algorithm simply, we can be able to disaggregate the total aggregated power to individual load power. That is appliance specific load data or appliance specific load profile at the output of my NILM engine. Like this. Next. Like this. This is my NILM method where all are connected to a single power bus. In a conventional case, intrusion method, each and every load is connected to a sensor and collected the data. Each and every load is having different load profiles. Rather than this intrusion method, I am introducing a non-intrusive load monitoring where I collect the aggregated data from the power bus itself. From this aggregated data, I would like to apply NILM method and disaggregate each and every load from this event detections. How these events will be detected? For each and every load, there are different types of loads available. What are the different types of loads? Constant loads is available. Which are constant loads? Your light, once switch on, same power will be drawn to that particular light. Whereas fan is a constant load. If it is maintained at a particular speed, it is a constant load. If I increase the speed, what happens? Current will increase. Okay, based on that, if I maintain a particular speed, the fan is also treated as a constant load. But it is in steps, constant in steps, like that. Okay? We have a marker. For a particular resistive load, I have switching on or off like this. The load profile will be like this. In an ideal case, I have on, some power will be drawn. Let us suppose for some 5 watts. Whereas for a fan load, that it may be a light load. For a fan load, it may be for a particular speed this value, and again it will reach to another speed, and again reach to another speed like this. Clear? In stepwise, if I maintain a particular speed, it is also a constant type load. Whereas transient loads are available. What are the various transient loads? Different states are available for a load. Which load has different states? Your washing machine. Washing machine, while soak the cloths, one power level is available. While washing the clothes, some power level is available. While rinsing the clothes, some power level will be available. Like that, different stages will be available. That is transition periods. Different transition periods. Like microwave oven, another case. Microwave oven also having different stages. For a 30 minutes, 30 seconds period, based on food item which is available inside that, if it is a normal food item or a food item which has very less calorific value, heat value, then it is fastly heated. If it is high calorific value, it takes much time to heat. Based on that, you need to increase or decrease the time period of that particular setting, such that you have a different load. I also given loads, types of loads. Next slide. These are various types. only on of different switching patterns of these appliances like washing machine or any induction stove, and continuously variable devices like driller. This is a continuously variable load based on your what is that? If it is drilling a wood, one type of load is available. If you are drilling a concrete, if you are drilling a wall with bricks, that is another continuously variable. And then permanent consumer devices. These are the permanent consumers like phone always connected to the power supply, or a bed lamp always connected to the power supply, or a CC camera always connected to the power supply. It has a constant power. It takes constant power, but 24/7 it is connected. Clear? In some cases there are connected loads also available, plugged devices also available. Most of the cases we leave the charger adapters which are connected to the plugged to the particular power supply without charging. Even then they consume energy because they have conversion mechanisms of AC to DC, DC to AC inside that particular charging adapter for getting a required 5 volts 1 ampere output from a 230 volts infinite ampere. Is it clear? So that even the plugged device also consume energy, but we neglect them. Whereas coming to this non-intrusive load monitoring or coming to the categorical analysis of each and every load, we would like to consider each and every load. What are the plugged devices available for particular plugged device? How much energy is consumed? That is also taken into account. Then only we can able to segregate and we can able to identify the loss where the loss is available. Clear? And this is the various characteristics: continuously varying loads and then multi-state loads. There are different multi-state loads also available. Based on these signatures, I have a combination of these three at a time, and I have an aggregated power. Aggregated power profile or a load profile is available. From that aggregated load profile, I need to verify at which state the load is increased or on or off. Event detection first case. In first step, I would like to get the events, on and off events of that particular load, and then segregate each and every type of load which is available at that particular building. We can able to disaggregate. Next. There is one of the popular technique, and for this there is a tool also available. LENDI-EEE is the tool, NLM toolkit, non-intrusive load monitoring toolkit. Presently, the research is going on this particular NLM, and the toolkit has different public data sets available. These are the data sets which are collected in a period of time, like a 1 year period, 2 years period, 3 years period. The complete data of voltage, current, and active power, reactive power corresponding to a particular load is given, and the aggregated submitters. For this particular building, there is a one submitter, and another building there is one submitter. Inside this particular building, there are different loads available. For that particular load profiles and submit reading is available for that. And another building, submitter is available, and inside that load will be varied from building to building or house to house. All the loads which are available in my house is not same on your house. The same loads cannot be available. Maybe varying. Okay, that variation is also available in that particular data sets. By using these data sets, first these data sets should be converted to a particular data format, an LMTK data format. That data format can be converted into by using a Hadoop file system, because there are different load profiles which are having different features: current, voltage, active power, reactive power. All the profiles will be available for each and every appliance and the submitter that will be available as .csv file, like a Excel sheet. For a particular building, I have 10 Excel sheets. Another building, 10 Excel sheets. Another building, 10 Excel sheets. Let us suppose. I cannot able to combine all these things. To combine and create a simple data file that is in a Hadoop file system. .hdf file. We need to format data .hdf file. Hadoop file system. This is one of the concepts in CSE. It is completely interdisciplinary subjects combining ECE, EEE and CSE. Okay? Then only we can able to survive in the competitive world nowadays. Okay? Without CSE or without AIML, we cannot able to publish even a single paper in Scopus journal. The conventional things won't accept. Reviewers won't accept. And that data format can be converted to these formats is given to a statistics. Statistics means they calculate the mean, median, average of all the values. If I taken readings for 24 hours, what is the mean value, median value, standard deviation? Based on that, it can be processed in the next subsequent steps for feature training or pre-processing is nothing but feature extraction. That is events detection is nothing but your feature extraction. Based on this feature extraction, first we need to train the model and then disaggregate the individual appliances. Disaggregation in the sense from the aggregation of load profile, we would like to disaggregate each and individual load profile. That is nothing but disaggregation. Energy disaggregation or non-intrusive load monitoring. Both are same. And this model can be evaluated by using some metrics. Clear? This is one of the popular tool, and there are different versions also available for NLMTK. There are NLMTK is one tool, and NLMTK contrib is another tool, and NLMTK eval is another tool. These are the three tools which are popular in this research area. Okay. Next. I already introduced the power line communication module. Power line communication, where that power line communication is done between substation to substation. Now I would like to bring that power line communication into an edge computing device. Edge computing in the sense inside home. I want to collect the data for signatures or feature extraction purposes. I would like to collect each and individual load profile data. Then only the machine learning can able to match that individual load profile from the aggregated load profile to disaggregate. So that I would like to collect the individual load profile data without using any additional power supply, additional network line. I would like to collect a particular data from that particular load. The data has to be connected to a particular hub through a separate LAN line or a Wi-Fi network. If it is a Wi-Fi network, Wi-Fi based sensor, presently in market there are different Wi-Fi based switches also available. If I connect a load to a Wi-Fi based switch, I can able to monitor and control that particular load by using Wi-Fi from anywhere. I can able to monitor that load from office itself. Clear? Even that devices are available, but those are failed due to the frequency or the bandwidth of the Wi-Fi. I have a Wi-Fi hub in this particular room. I cannot able to get the signal for 10th room from this. Clear? The bandwidth is limited. We cannot able to get the Wi-Fi signal throughout the home in a smart building. That is the major drawback. Without the signal of that particular Wi-Fi, we cannot able to monitor that particular device because there is no signal at all. We cannot able to reach that particular load, which is at the extremity of that home. I have three rooms, that is 2 BHK or 3 BHK have a living area of 1500 SFT. In 1500 SFT, I have a hub, that is Wi-Fi router is available at a hall at somewhere nearby my IoT devices like TV, smart TV and so on. But this Wi-Fi strength is not possible and Wi-Fi is not available, the signal is not available at the kitchen, which is the extremity of that particular home. That all the devices which are available in that particular kitchen cannot be controlled by Wi-Fi. That's why I would like to bring the power line communication which is available in the substation to substation communication into home. This is my own case and it was patented. I have a master device. I have a master device which is available at the Wi-Fi range. Like your Wi-Fi hub is available, and this master device has a microcontroller which accesses the Wi-Fi base, and this master device is connected to different slave devices which are connected to each and every load. My slave devices are available at each and every load, where the slave device has a power line communication and a master device has a power line communication module. Where we have a phase neutral which is available for each and every load. We already erect the complete power line to each and every load. Already I have a phase and neutral line which is erected in an electrical network in my home itself. I can able to use that particular electrical network as a communication medium also, such that each and every load is connected to that particular phase and neutral, and the load data corresponding to that particular load by using a power line communication, I can able to get the data, voltage, current, active power and reactive power data corresponding to that particular load through a power line itself. The same power line, I can able to use that power line for energy transmission and the data transmission also in a bidirectional way. So that I cannot able to build a separate Wi-Fi mesh network, because my Wi-Fi signal is limited, so that all the loads cannot be able to get the data or get the data from all the loads from using Wi-Fi data. So that I would like to connect it to a wired medium. All the slave devices are connected to each and every node, and it can able to get the data to a master device, and master device is connected to Wi-Fi from remote location also by using a mobile app. I can able to control each and every device from master and slave network. I can send the command signal to a master device, switch on a room 1 light. That is my command, which is given to a master device, and that can be transmitted through a power line to the slave device, which is available at that particular load, and corresponding relay which is available at that particular load will be switching on or off, so that I can able to control the device. In the monitoring case, if this is on, the complete power supply which is given to that particular load and voltage and current values are sensed by the sensor, and the same power line will be acting as a data medium and send the information to the master device, and the master device will be connected to a Wi-Fi, and we can able to monitor that particular device also in the reverse manner. Complete scenario will be given in the next period. Next. Tell me.
Centralized energy management or decentralized?
This is only for home purpose. Inside home. Outside home, remotely we can able to monitor. This is for smart home only.
That is decentralized.
Decentralized.
Overall system is centralized.
Centralized.
Centralized management we are getting signal for decentralized.
Decentralized. Next. This is the complete scenario of a master device and slave device. For each and every master device, this is my master device. Power supply and sensor network completely available inside the master device and slave device. In a master device, we have a embedded microcontroller with Wi-Fi connectivity, where we can able to send request and get the response from by using a MQTT protocol or HTTP protocol. Do you know? By using MQTT or HTTP protocol, we can able to get the response and get user request to that particular embedded board. From this master, we can able to control slave, any slave. Okay. Next, these are the advanced techniques. AMI is one of the advanced technique, and smart energy meters. Even in smart energy meters itself, NILM technique is an advanced tool which is available in smart energy meters. That was not available in India in market. Here, but in Europe countries and Canada, NILM based smart energy meters are available. Here, they have a categorical load details will be available in an energy meter itself. At any given point of time, it can also store the data. I would like to see the last 15 days of energy consumption corresponding to my AC. You can able to see, and you can download to a Excel sheet directly in the web-based app itself. And these are the various tools available for energy management. Energy management system for energy management, we have Cylinder Electric tool, Johnson and Honeywell. These are the three tools available for different energy management platforms corresponding to HVAC, lighting, and various real-time based controllers inside the building management control. These are the three tools available for energy management system. Whereas for a smart grid management, we have these three tools: grid point, GE digital. This is completely on GE, General Electric. Digital energy is Gridio. Gridio is a app name. Grid point, and this is a PA system which is collected real-time data from the grid. For grid management, these are the tools. For energy management, corresponding to building energy and energy corresponding to a particular load, this is the tools available. And for a building energy management separately, we have tools corresponding to BEMS, building energy management. These are completely web-based tools which has a simple web-based app or a mobile app. You can able to control every tool, every load itself. These are the tools available. And then this is for BEMS, building energy management. Next. And for demand response and load management, these are the tools. NLX, NRMOS. NRMOS is nothing but NREL from an NREL, and Auto Grid Flex. These are the three tools available for demand response and load management. And for renewable energy management, like solar forecasting, wind forecasting, like renewable energy. Homer energy is one of the tool. Do you familiar with Homer? There are so many tabs available in Homer. You can be able to get the data corresponding to a particular location also. If you feed the data, feed the location, let us suppose Vizag, particular latitude and longitude. If you give that latitude and longitude, you can get the complete solar data, irradiation and temperature based solar data from this Homer software, and it will generate reports also with neat graphs. Reports also it will generate. Clear? That is Homer energy. And WindPro is also another software which are completely open source softwares. You can able to directly download and you can utilize open source software itself. WindPro is another tool where wind based data, wind forecasting data will be available here. And RE Optline, this is done by NREL, National Renewable Energy Laboratories. This is software tool which is developed by NREF for renewable energy management, renewable energy optimization tool, that is RE okay, optimization of renewable energy cases. And analytics and optimization, these are the various tools. Energy Hub and Watson's. Watson's is not available in India, and SAP Energy Management is also another tool. These two are available in India, and Watson's is not available in India. Next. And for smart metering and IoT solutions, these are the tools: Etron, Landis, Siemens MindSphere. These are for IoT-based applications. For IoT applications and data management using IoT technology in a smart meter case, these are the tools. And we can able to monitor climate situations also. What is the weather data, at which weather, or based on weather data only you can able to predict the solar. So that weather data is also important. For the climate and environmental monitoring, for smart city, we can able to connect all the things to smart. Climate is also one of the key parameter. So for that, these are the tools: weather underground API and air visual. And for urban planning and simulation, we can able to get the planned 3D models also available in this particular tools. We can able to plan a particular city in a smarter way. For that case, the 3D models and some city models also available here in this particular case. How the normal urban city can be transformed into a smarter city by using some city models, where it has to be implemented to get into a smarter way. That tools will be available. This is an urban footprint and city formula. It is like your ANSYS or AutoCAD. Do you know AutoCAD? There we can able to have 3D models, buildings and 3D model, energy management plans also available. The complete city plan is available in this. Previously I already shown one energy power system is available. That model is drawn by using these tools. City formula and urban footprint. And for cyber security, while collecting all the data and connecting each and everything to a IoT, your personal data is also fed into a cloud-based platform. I can able to access your data, you can able to access my data. There is a security purpose. For a particular need or for a particular home or a building, some data has to be public and some data has to be private. That security needs has to be inserted into a smart grid technology. For that, cyber security solutions is very much needed. Okay, due to attacks, there are cyber attacks will be available. Due to the cyber attacks, I can able to monitor your device inside your home also. If I connect to your internet, I can hack your password of Wi-Fi. I can able to monitor your device and your daily routines also. I can able to control. Likewise, there are different situations happen due to that dark trace and FireEye and dark trace are the two tools where cyber security attacks and cyber security provisions will be, privacy concerns will be modified in those particular tools for a particular smarter city. Next. And these are the basic research directions. We can able to get research on advanced storage solutions like pumped hydro is one of the trending research. Pumped hydro and batteries, various batteries available. Most of the countries are researching on different batteries. Only lithium-ion batteries are available in India. Most of the cases, and lithium polymer in some applications, lithium polymer and lithium ferrous is also available in some cases. But sodium batteries are also available, hydrogen batteries are also available for higher energy capabilities. Based on that, we can able to transform higher energy rates. Most energy will be stored into that particular batteries. Okay. That battery technologies will be in advanced research, and then pumped hydro is also for storage purpose, and then compressed air is also for storage purpose. For a renewable energy case, we need a storage. I have a solar panel of 100 megawatt. What is the storage capacity? 100 megawatt battery is of this much room size. I cannot able to afford that particular room size battery. It may explode. Lithium ion battery is very dangerous. Here, in most of the cases, we see electric vehicle batteries also blasted. Even if you transport or if you carry electric vehicle battery inside a lift also, it will blast due to electromagnetic interference. Clear? And we have a research opportunity on real-time monitoring and control. Some advanced sensors available. Based on that advanced sensors, we can able to optimize the energy distribution cases, and we can able to meet demand and generation in an optimal way. That can be done. And demand response programs, various demand responses will be demand response strategies by using different techniques, using data, time data, real-time data, and consumption patterns and peak loads. We can able to get the peak shaving curves. We can able to cut down the peak at that particular peak time. We can able to shift the loads. Shiftable loads are there, non-shiftable loads are there. That shiftable loads we can able to operate in off-peak time, and emergency loads will be operated in peak time, so that energy will be reduced. The demand at that peak time will be reduced, so that the tariff will reduce corresponding to that particular consumer. And sustainable energy decision is another research area, and grid EV to grid integration is another area. Vehicle to anything, V2X, V2 grid, grid to vehicle, and vehicle to home. So many technologies will be available. Next. By using the data, we can able to ask using AI tools and machine learning applications. We can have the predictive analytics corresponding to energy data. We have lot many data is available. For that, we can able to get the predictive analysis. At which condition? Let us suppose this fan is available. I have a 24 hours or a 1 year of data corresponding to this particular load. Due to this particular load data, I can able to predict at which condition or at which particular period this has to be maintained. Beforehand, or without any loss of a particular load, damage of a particular load, beforehand I would like to predict the maintenance period, and I would like to maintain that particular fan. Maybe a bearing may complain, or high current, it will take high current, and that particular winding may damage. In those situations, continuous high current situations will be happen. Then we will give an alarm or alert to the user such that it may damage the winding, so that it has to be maintained within hand. Clear? Rather than after damage, we need to predict the maintenance period beforehand by using the data. That is also another research area. And privacy protections by using cyber securities, and from waste to energy, that is also a research, trending research, waste to energy and climatic strategies. These are the various research strategies or research scope in energy management case and smart cities. With this, I conclude my lecture. If you have any queries, bit louder.
And we are going to integrate it system related. We will soon have I just want to consider the artificial development as an application. So, how can we define an accuracy of the system? That is going to take and second is, if you would like to take an optimization technique,